In this video, I am going to go over the online final exam practice test that covers measuring matter and atoms section of the final review packet. So in this first problem here, it says to find the density of an unknown irregular shaped object. All right, it gives us the mass of the object, and it tells us a little bit about what happens when you put it in a graduated cylinder. So when we are working with density, density is mass divided by volume. The mass is real easy. It just gives us that in the problem. You have 85.35 grams. Now the volume takes a little bit more effort. It's saying you have this graduated cylinder and you have 11.30 milliliters of water in it. And it says you drop in this irregularly shaped object and the volume goes up to 18.83 milliliters. Well, we could use those numbers to figure out what the volume of the object was. And really all you have to do is take the difference between those two numbers. And that difference ends up being 7.53 milliliters. And that's what we put in the equation. So now when you do 85.35 grams divided by 7.53 milliliters, you get the density of the object, which I believe comes out to be 11.3. All right, for the next problem, it says to convert 0.00510 to scientific notation. A couple things to remember about scientific notation. If the number you're starting off with is less than 1, which this one is, your exponent should be negative, so you know it's not that example. Now the other thing you have to do is whenever we do scientific notation, for us it's always one number then the decimal point. So you have to figure out how many times you have to move the decimal point to get it behind the first non-zero digit. It took 3 times to move it to get it behind the 5. So what you should get is 5.10 times 10 to the negative third. The negative 3 represents how many times you moved it. And we want to match the significant digits to the significant digits in the problem, which is 3. So that's what we end up getting there. Number 3 is talking about decomposing water to get hydrogen gas and oxygen gas. So what you are doing is starting off with water molecules, and it's going through decomposition, and you're going to get hydrogen bonded to hydrogen and oxygen bonded to oxygen. So what you are doing is breaking bonds and forming different bonds, so that's telling you it's a chemical change. Now the only one out of these examples that is a chemical change is electrolysis. So you could do this reaction if you have the right setup by passing electricity through that water to break the hydrogen and oxygen bonds and form these new bonds. Now these other options here, recrystallization. An example of that would be if you have a solid dissolved in some sort of solvent. So say you have salt or sugar dissolved in water and you want that salt or sugar back, you could just boil off the water or let the water evaporate and the solid will recrystallize. Paper chromatography is a way of breaking apart a mixture into its constituent parts. There's different types of chromatography. There's paper chromatography, there's gas chromatography, and liquid chromatography. There's different stuff, and a lot of times they're used for analytical methods. So really what's going on with paper chromatography, for example, if you have some sort of ink that is made up of a bunch of different colors, you can get chromatography paper, and if it's water-based ink, you could put a dot of the ink on the bottom of the paper and dip it in the water and let the water move upwards over that chromatography paper. And the different colors are going to separate out depending on different things. Basically, how soluble they are in the solvent or how much they will move through the medium, which in that case is a cellulose. So that is a physical change. Distillation, we did an example of that towards the beginning of the year. That's if you want to separate out 2 or more liquids and maybe even one solid that might be in solution. And that is based off their differences in boiling points. So like alcohol and water, you'd be able to separate that out. And then filtration would be if you have a heterogeneous mixture. So say like sand and water and you want to filter out the sand or something like that. Right, so electrolysis is the only one that works for decomposing water. converting 6,500 milligrams to kilograms. So if you know the order of the metric prefixes, you can just move the decimal points around. The reason why that works, like say you forget the exact order of all those things, you can do a conversion problem for this. And what I'm going to do is start off with milligrams. So I'm going to put milligrams on the bottom because I want the milligrams to cancel out. And instead of going right to kilograms, I'm going to go to grams. Now, what I like to do is the larger unit is the one that I give the number 1 to. Now, we know a milligram is 1,000 times smaller than a gram, so you need 1,000 of them to equal 1 gram. So now milligrams will cancel out. What you have right now is grams, but what I want is kilograms. So I'm going to put grams on the bottom in the next step, so they'll cancel out. Kilograms up top. Kilograms is the larger of the two units. It's 1,000 times bigger than a gram, so you need 1,000 grams to equal 1 milligram. So now what you're doing is 6,500 divided by 1,000, and then divided by 1,000 again. So if you're going to write this out, when you divide by 1,000 the first time, that's moving the decimal point 3 places. And then dividing by 1,000 the second time for this next step over here, you're going to move the decimal point 3 places again. So there's 1, there's 2, there's 3, and that's where the decimal point ends up. So we end up getting this one, again matching the significant digits to the significant digits in the problem, and we're good at that point. For the conversion between degrees Celsius and Kelvin, if I give you degrees Celsius and ask you to go to Kelvin, there's two main things you have to remember with this. Kelvin is the larger numerical number, and it is bigger by 273. So all you have to do is take that 35 degrees Celsius, add 273 to it, and you get 308 Kelvin. All right, if I gave you Kelvin and asked you to go to Celsius, then you would subtract 273, because remember, Kelvin is the bigger number, it's bigger by 273. How many significant digits are in 51,010 meters? Now, when you're asked for a straightforward problem like this, significant digits, the first thing you should look for is if there's a decimal point. There's no decimal point here, so that means you're going to start from this side and not count any of those initial zeros you get to. And once you get to a non-zero number, you count up everything that comes before it. So for this one, it has 4 significant digits. Now the next problem has a decimal point, so now you start from the other side. Now you cross out those initial leading zeros until you get to the first non-zero digit, and everything on the other side of it counts now. So you have 1, 2, 3, 4, 5. All right, always look for the decimal point first. It's going to tell you which side you start from. Any zeros that get sandwiched in the middle, they always count. In this first case with 51,010, that zero on the right there is just considered a placeholder. Same thing with the next example, the zeros at the beginning, they were considered placeholders. A compound and a heterogeneous mixture in that order. All right, so we look at this first example. Baking soda, which is just sodium bicarbonate, that is a compound. And then iced tea, I would say, is a homogeneous mixture. Now, for something like that, it's assuming that the iced tea doesn't have any like undissolved sugar in it, or there's no like tea leaves floating around in it or something like that. It's just this, brownish kind of liquid. You can't tell that there's more than one thing in there. So that is the one that's actually a compound and a homogeneous mixture. If we look at the other examples, just to make sure, sodium is an element, and table salt is sodium chloride. All right, so that ends up falling under that compound. Sugar water, assuming it's all dissolved, is homogeneous. Carbon is an element, so that's not it. Now, carbon dioxide is a compound, but it was asking us for a homogeneous mixture. An Italian salad dressing is not homogeneous. That is something where you would see the layers separate. You would probably see like the spices and stuff like that in there. You could tell that there's more than one thing in there, so that is heterogeneous. Converting 300 with a decimal point milliliters to liters. Now, again, you could just move the decimal points if you know how to do that. But if you wanted to write the workout, just to make sure, you start off with this 350 milliliters. Whatever units you start off with go on the bottom. And we're looking at liters, so they go up top. So remember, what I tend to do is put a number 1 with the larger unit. And a milliliter is 1,000 times smaller, so it's going to be 1,000 milliliters in 1 liter. So you're dividing by 1,000, which is the same as moving that decimal point 3 places to the left, which means you get 0.350. All right, a little bit about atoms. How many protons, neutrons, and electrons are in bromine? 81. That has a -1 charge. Bromine, off of the periodic table, it has an atomic number of 35. So that means 35 protons, which all of these examples have. Now, the mass number 81, what happens is the protons and neutrons add up to the mass number, which is 81. So for neutrons then, that would be 46. So that means that one's out, and that option is out. So we really have these middle two to pick from, and the way we figure that out is a -1 charge. So a -1 charge means you gained an electron because the electron is the negatively charged particle, and you compare that to the proton because they are the particles that have charges. The neutron has no charge, which is why I put a 0 here. So a -1 charge means you gained an electron, which then means it's that one. All right, so that was the review for the measuring matter and atoms part of the final review practice test.